All right, we are in grade 10. We are doing mathematics. We are looking at measurements. In our previous lesson, we looked at measurements and we were focusing on total surface area. So in this presentation, we are going to look at volume. We are basically going to look at volume. Now, when we talk of volume, we are simply talking about amount a container can hold. Amount a container can hold. Amount a container can hold. Now, these containers are of different shapes. They are actually prisms. These containers are actually prisms. All right. So now, if they are prisms, then it takes us back to um, our subject on it takes us back to our subjects on prisms, but this time, like I've said, we will be focusing on the volume of this prism. Now, let's look at how we find a volume. There is a formula which says that if you want to find a volume of any prism or any container, like our definition says, you will have to remember that volume is equal to cross-sectional area multiplied by length. Multiplied by length or height. Okay, this is actually the formula that we usually rely on in this aspect. Okay, now if we know that volume equals to cross-sectional area multiplied by length, then this cross-sectional area is the most important part. It's the most important part to identify when you are looking at a prism. Let's look at it uh, 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 from this angle. You need to know that if you have a cylinder, okay, let's say you have a cylinder like this one. Now, if you want to find the volume of this cylinder or the amount this cylinder can hold, the amount of matter it can hold, whether it's a liquid or anything, we need to consider this section here, this circular section. This is the cross section. Okay, this is the cross section of this cylinder. Now, this becomes the height. Okay, that means here we are talking of the cross section. The cross section, but here now it's the height because the cylinder is upright. Okay, if our cylinder had been toppled like this, if our cylinder had been toppled like this, all right, then we would still have this as our cross section, which is a circle. All right, It would still be our cross section. But this now is no longer the height, but the length. Okay? That is why in the formula we said length or height. It depends. It will be the length when the cylinder is toppled, and it is going to be the height if the cylinder is upright. Okay? Now, meaning that the height is vertical to the horizontal plane, the length is parallel to the horizontal plane. Okay? Now, that is very important. So we need to be able to identify this cross section. We need to be able to identify this cross section. So when we talk of the cross sectional area, the area of this cross section is going to be the area of a circle, because the cross section is a circle. That means the volume here is going to be the area of a circle, all right, which is we are going to say area of a circle. Why? Because the cross section is a circle. Then we multiply this by the length of this cylinder. Okay, so basically this becomes uh, uh, it becomes this. So the volume for the area of a circle is always pi radius squared. Okay, pi radius squared. Then we multiply this by the length now. Okay, so that means the volume for a cylinder would be pi r squared L, pi r squared multiplied by L. Okay, where this pi is a constant. This pi is a constant. This pi, it's usually equal to 3.142. Okay, it's a constant. It's always like this. Now, um, um, R here stands for the radius of that circle. And then the length stands for the length. L stands for the length. All right. So now the radius, remember, if we have a circle, the radius is any length, any distance from a point on the circumference to the center of that circle. So if this is our circle, our circular section, then if this is the center, a radius will be any line from the center to a point on the circumference. That would be the radius. So we take the radius, we square it, and multiply it by pi, multiplying it by length. That would be the volume. So it takes us back to the definition of our volume being the cross-sectional area multiplied by the length. Okay. Now let's look at one other example. Now let's say we have our cylinder. In this case, as we have this situation here. Let's say we have this situation here. Let's say we have this situation here, and then radius here is 5. No, not 5, say 50 centimeters. And then let's say the height here is 120 centimeters. Okay, and then you are asked to find the volume. So they say find the volume of this cylinder. Find the volume of the cylinder. You are asked to find the volume of this cylinder. Okay, what do you do? The first thing to identify is the cross section. This, the cross section. The cross section is a circle. All right. Now, if the cross section is a circle, we know that volume is equal to volume will be equal to cross sectional area, okay, multiplied by, this time we have height, multiplied by the height. The height because our cylinder is upright, okay? Now, since the cross-sectional area is a circle, that means uh, cross-sectional area here will be the area of a circle, which would be pi radius squared times the height of that circle. Okay, so now our pi is going to be 3.142 times r radius, which is 50 centimeters. Then we square this because the formula says it's squared. Then multiplied by the height, which is 120 centimeters. Now let's square this 50 first. We are going to have 50 times 50, okay? 50 centimeters by 50 centimeters. So we are going to have 3.142 times 2,500 centimeters squared times 120 centimeters. Now, centimeter squared times centimeter is going to give us centimeters cubed. Okay, let's multiply the constants and the coefficients here. We are going to say 3.142 multiplied by 2,500 multiplied by 120. So our answer is going to be 942,600 centimeters cubed. That would be our volume. 942,600 centimeters cubed. So that means when it's easy, as long as you know the formula, as long as you know this formula for the area, this one, it becomes easy, because once you have identified the radius and the height, you are just going to substitute in this formula. The pi is always a constant, it's the same every time. Now that then you go through arithmetic until you get to the final answer. Okay, that is how you find the volume of a cylinder. Let's say you had this shape now, not a cylinder, but this one. You had you had a cuboid. You had a cuboid this time. Okay, you had a cuboid like that. You had a cuboid like this. Let's say now you have 15 centimeters here. You have 60 centimeters here, and here let's say you had 180 centimeters. Okay, then you are asked to find the volume of this shape. This is a prism actually. It's a solid. The volume of this is going to be, you remember, volume is equal to cross-sectional area. Cross-sectional area times length. All right. Now, the cross-sectional area in this case is going to be this rectangle here. The end section, cross-section is going to be this rectangle here. Now, if the cross-section is a rectangle, that means cross-sectional area is going to be area of a rectangle. This is going to give us area of a rectangle. It's width by height, So width multiplied by height, then multiplied by length. So that means the volume would be equal to WHL, where W is the width, H is the height, L stands for the length. Now, all we need to do would be now to substitute here. W, which is the width, is 60 centimeters. We multiply it by a height, which is 15 centimeters. And then we multiply that by the length, which is 180 centimeters. All right. So centimeter by centimeter by centimeter will be centimeters cubed. Okay. Now we multiply the numbers there. We have 60 times 15 times 180. So we are going to have 162,000 centimeters cubed. That would be the volume. 162,000 centimeters cubed. 162,000 centimeters cubed. So this becomes the volume of this shape. Once you know, if you can just remember this, volume is equal to cross-sectional area by length. Let's say you had this shape. Say you had this shape here. So you had this shape here. This is it, okay? Now, you are asked to find the volume of this shape, okay? What you need to understand is this is the cross-sectional, the cross-section, this one. So the cross-section is a triangle, all right? The cross-section is a triangle. So the volume would be cross-sectional area by length. So the cross-sectional area would be area of a triangle. An area of a triangle is half base by height, then multiplied by the length. This would be the length. So the height should be somewhere here. The height should be somewhere here. Because remember that the height is always perpendicular to the base. So this, if this is the base, then this should be the height perpendicular to the base. Don't be mistaken, okay? Now that means we need to know this dimension. Let's say this dimension here is 10. Let's say the base here is 25. Let's say the length here is 90. Okay, they are in meters, okay? They are in meters. Now, what do? You just substitute and say, okay, I have half base. Base is equal to 25 times height. Height is equal to 10. Then times length. Length equals to 90. All are meters. So that means meter by meter by meter is going to be meters cubed. That would be our unit here. So now we are going to have let's say 2 here, into here goes once, into this it goes 5 times, okay? So 25 by 5 by 90. 25 times 5 times 90 is going to be 11,250. Like this, meters cubed. 11,250 meters cubed. So this becomes our volume in this regard. All right, this becomes our volume. Okay. Now, yeah. So it will depend on the shape that is given. Then your ability to identify the cross section and the other dimensions like the length or the height. Then uh, using the general formula for the volume, which is cross-sectional area multiplied by length. All right, this is the end of our presentation.